Continuing types of reactions, we're going to look at combustion. And again, there's nothing new here. I've done all of these with you. It's just the idea of identifying the reaction as combustion. So don't think yourself into believing there's more work than there is. The general dead giveaway of a combustion reaction is the plus O2. If you see that, no matter what happens on the other side, it's combustion. This looks very much like synthesis. Two separate things became one. But when you burn methane, two separate things remain two. And I've seen students call that double displacement. If you burn methane with insufficient oxygen, none of these equations have been balanced here. If you burn methane with insufficient oxygen, you are going to get all the possible carbon compound outputs, CO2, CO, and carbon, plus water. And your brain might try to say, that's decomposition. Look it. It's a thing over here, and it's a way lot more than before. Does not matter. Plus O2. That's the giveaway. No matter how much other stuff is around here, when you see plus O2, it's combustion. Now, there's a slight complication. Sorry, I meant to illustrate it with that. There's a slight complication. All of these reactions look like synthesis. 2 becomes 1. 2 becomes 1. 2 becomes 1. And I'm a teacher and we like repeating ourselves. 2 becomes 1. And we said combustion involves oxygen. So you're probably going to identify these as synthesis, but they are technically combustion as well. I guarantee you all of these will produce flame. So these are all considered combustion reactions. But some teachers are teaching it that this is synthesis and only oxygen is combustion. That's not correct. Both are. But what are we going to do? I don't care. If you call this synthesis for our needs, I don't care, because we can't show you these reactions. They're all illegal in school. So I'm not interested in hair splitting with you. See that, call it combustion. Don't worry about this, call it synthesis. It's good enough for our needs. The last reaction we're going to study is double displacement in the form of an acid and base. This is an acid, that's a base. Acids begin with H, bases end with OH. Not 100%, but good enough for us. So we have hydrogen is dating chlorine and sodium is dating a cluster called OH or hydroxide. What you see happening is a swap out. Chlorine moves over to sodium. Hydroxide moves over to hydrogen. That I've colored them differently makes you understand that this is a package attached to the sodium. So the OH gets its name called hydroxide. It is a fraction of water that behaves like a halogen, like chlorine all by itself. It's something like this. Here's a water molecule, a plus, a -2, there's another plus. If we go along here and just go rip and tear off the hydrogen got torn away and his bloody electron is gone. It's over here. So we wind up with this H positive and this cluster, this fragment of water called OH negative. And he is so desperate to find another negative. He's like, where's mommy? Where's mommy? He'll attach himself to anything negative. And the OH, she's like, my child, oh, we're going to find it. She'll attach herself to anything positive. So if you break apart a water molecule and introduce a non-metal to the hydrogen or a metal to the OH, you will form an acid or a base. This is going to take several days on its own to go through. So I'm only including it here for your purposes summary later. Don't think you have to learn about neutralization from this single slide. And that's the end of it for the moment. Now, the neat part about this is this is the acid in your stomach, and this is Drano. Like, this will peel the skin off you. So will this. Pure sodium hydroxide is so powerful, it can scratch, like erode glass, and it uses oven cleaner, and you can even clean baked on tree sap off of table saw blades. And pure hydrochloric acid to dissolve a car. You mix the two together and you get salt water. So there's some interesting carnival tricks that can be done with this reaction if you're prepared to risk your life. You got to get this mix bang on, and you could take two horrendously dangerous materials and just make yourself a piping hot glass of salt water. Get the mix wrong, kiss your lips goodbye and everything that comes after.